Okay, so hi everyone. Today we're going to solve another problem, that is 451 LeetCode, sort characters by frequency. It's a medium level problem, although I will say that it is not uh, that much hard. It's more like a easy level problem, but it's a good quality easy level problem. And the like to dislike ratio is very impressive. So let's start this problem. So we're given a string s and we need to sort it in such a manner that it is sorted in a decreasing order based on the frequency of the characters. So what do we mean by that? So for example, in this case, you have this string, right? Tree and tree. Fine. So T characters, there is only one T character, and R character is only one. E character is two. Now you need to sort this string in such a way that after sorting, it's in a decreasing order of its frequency. So for example, E is occurring twice and E is the largest out of them. So E will be at this position. All of the E's will occur at beginning of the string. And then from this point you have R. You can put R because R and T of equals frequency. So you can either put RT, or you can also have this string as TR, right? It doesn't make any difference. So that's one thing. And another thing which you need to take care of, so for example, you can see that there is uppercase, lowercase and digits as well. Wait, what is this? Okay, so you have uppercase letters and lowercase letters, which means the string could have lowercase letters, it could have uppercase letters, and it could also have digits, right? So for this purpose, we will be using, so the first approach is to literally do what the question is saying, that sort them based on their frequency, which means that if we have a vector to store the frequency, then we will be using a vector and it will have 128 characters. The reason for that, using a 128 character vector is because these uh, characters will have an ASCII code which is in the range of 0 to 127, which makes it perfect for our vector to be of size 128, so that we can access the frequencies of these characters with their, and associate every index of this character as the ASCII code of the corresponding character. So now we will store the frequency. I will start iterating over the string with having a variable n that is equal to s dot size. Now I plus, so I is less than n, I plus plus, and you have frequency of s of I plus plus, right? And then I will sort them. So s dot begin, s dot end, and now I will use a lambda expression. So you will have, and the um and the character A and the character B as a reference that we'll get from the iterating over the string in the sort by default sort implementation. So this is nothing but a comparator, and we are writing a custom comparator for it. So the thing is, if s is equal to, if the frequencies are same, right? Now consider this case where t value is 2, r value is 2, and e value is, let's say, 3, right? So in this case the string should look like this. The string, if this is the default implementation of the string, is t t r r double e, right? Now string would sorry, so the string should look something like this: e e, and then r and t t, or e, there should be another e, r, not r, this time we can have t r r. Out of these two, the string can be of any, out of these two, if the string is of this instance or this instance, then it's a good string, it's a sorted string. But if we keep a condition but if the condition is that the frequency should be, let's say I keep this condition as return, so frequency of A is greater than frequency of B, right? Now I am iterating over this string, and I find that frequency of t. So frequency of t, what do I mean by this is, if we only have this operation, if we only have this condition, then this could also look something like this. So e is up before, and which is good, which should be. But then we have rt and we have rt, or we can also have a string like this, tr, tr, depending on where the whether t is first or r is first in the string, right? So this could be the string, but this is not a sorted string, right? In order to get rid of this condition or this behavior, we need to say that if frequency, and this will only occur if the frequency of two characters is same. So frequency of a is equal to b, which means if this is the case, then then keep whatever is first in the alphabetical order, although it's not given in the question that you need to keep that first element, that you need to have a priority over if the frequency is same, then you need to give priority to their alphabetical order. It's not given in the question, but I'm just saying it in order to avoid this case, right? And after sorting them up, we are done, and we can just simply return the string. So let's see if this will work. Okay, LeetCode is taking too much time. I have no idea why. Okay, it is accepted. And let's hit on submit. Okay, it does work. And and it's not a very optimal code. So now we jump to the time complexity and analysis part. So time. For this question, you can easily see we are doing a linear work, again a constant work, and then we are sorting the string. So if string is size is n, if the size of the string is equal to n, then it's taking upper bound of n log n time, right? Even the average case is n log n time. So which makes the time complexity as n log n, and space complexity for this case, as you can see, we are using a frequency array which is of 128 characters, which is a fixed character, and we know this value. So it's not going to grow exponentially or decrease exponentially, which means it's a constant space. And another thing as well, it's a constant space. Now one can say that it's a constant space, but the hidden side, but in the hindsight, one can also ignore the fact that we are using an inbuilt in sort function, and this sort function use intro sort, and and intro sort sometimes, or I think in previous implementation, it's a recursive algorithm, which means the time complexity could be n, right? But it's more like a language dependent, because it will be found only in C++. So I think in theoretical and in generalized concept, it is safe to say that time complexity is constant for this case. Now back to the question. Now, can we improve it? Can we improve it? Yes, we can. We can use a very popular concept called bucket sort. Now, if you don't know anything about bucket sort, you can obviously have some introduction of it. Otherwise, I'll be giving you an introduction. You don't have to be worried about it. So now let's consider an example. So let's take tree only. So you have tree word, right? What is their frequency map? The frequency map will look something like T has frequency 1, R has frequency 1, E has frequency 2. Fine. So bucket sort says that you can create, so this is your array, right? So this is your array and it has the indexes. So the indexes will be your frequency, right? And every index will have a bucket associated with it, right? So indexes are 0, 1, 2, and 3. So at one index we have T, and at one index we also have R, which means that at this frequency we have these characters which has the frequency of 1, and in this bucket of 2, the frequency is 2, it will have only E. Fine. Now if we travel this bucket or this data structure in this direction, then we will realize that if, let's say, I am on this last character, that is 3, and this is my answer string that I want to return, right? So this is 3, it doesn't have any element, so I will simply move to the other element. This is E, and this is 2 frequency, and it has some elements, which means we will be having E 2 times the number of frequency it relies on. and then we move to the another index, and then we have 1, which means every element will have a frequency of 1. So we will start with t, and it has the frequency of 1, so we'll stop there. And then we start with r, and it has a frequency of 1, so we'll stop there. And then we move to another index that is 0, and it doesn't have anything, so we won't add anything. And then we move out of the bound, and it is the final string that we have with us, and that is our answer. Now there's one problem. No, not a problem actually, it could be a follow-up to make this question a little bit more harder, or I wouldn't say harder, it's just some extra, in order to avoid the linear time, it could be done. And that is, if we have a condition that tr, we can also, and this string could also be, if we have store r earlier and then t, this string would look something like this, right? So if it's a condition that RT is not possible, and sorry, if this is a condition that TR is not possible, right? And the only possible string is sorted string is EERT, which means in the alphabetical order, then we won't be able to use the bucket sort concept. Or no, actually we won't. We would be able to use the bucket sort, but then we need to manually sort the characters that are inside this bucket. So for example, we have TR, right? Earlier, because we find T earlier, so we pushed it. And then I find R, so I pushed it. But no, this shouldn't be the case. R should be there and then T, which means that we need to sort these elements, right? And in worst case, it would be n log n, because there could be a case or a string where A, B, B, C, C, D, D, right? Every element has the same frequency, which means that every element will reside in A, B, C, D, and then it needs to be sorted out. So the distinct sort will be almost equal to, or let's say every element, yeah, so the distinct sort will be log of 26 log of 26, because there are distinct 26 characters. And so yeah, this could be a case. But then if we have n, this is a constant time, but if we have n strings, right, for them for example, if I have n characters, and they have different frequencies, then it could be a little expensive. But no, I think it still would be n time, right? It still would be n time. So let's jump to the main question. That was just a follow-up that I was discussing. And now we have this string, it's a good answer, and we return it. So we have E earlier, and we have T and R here. So that is the concept. So this is the bucket sort. This represents a bucket, and the index represent the frequencies, and the index represent the frequency of the bucket. So let's start implementing this code now. So I'll be keeping the n because I need the size, and then I will choose to have an unordered map, right, which is of character is the key and int is the value, that is a frequency. So we have an unordered map, and yeah, so now we are good to go and store the frequency. So I will say char c of s, so which means this means that we are going to it. So this is the c is every character that is available in the string, and then I will store the frequency. So frequency of c plus plus. Now we need to create our data structure for the bucket. So vector of char, right, and this is our bucket. And the size, what will be the size? So the maximum size could be if we have, let's say if we have a frequency that is equal to, frequency could be n, right, the maximum size. Because in worst case you have a string which is a which has same characters, then the frequency will be the size of the string, and this is the worst case, right? So that means n plus 1, because we are accessing indexes, so it has to be plus 1. Now let's add these values into our bucket. So we are going to iterate over the map, and it will be auto. So now we have a character ch, and we have a frequency that we are extracting or destructuring from the map and from the frequency map. Now bucket of, at this frequency, right, this is the index, dot pushback this character, right? So basically this bucket is nothing but a vector, and this is the index. So every index of or the frequency will point to a vector which has the characters that are associated with that frequency. And yeah, now we have formed the bucket. So now uh, let's start the iteration. So I is equal to, so what is the worst frequency that we can have? That is equal to n. Now I should be greater than 0, because if frequency is 0, then we don't have to do anything, because we are not going to store any element, right? And I plus plus. Now we are going to have a string, right? In this case, we are going to have a vector. At every ith of the bucket, at every, in every bucket we are going to find a vector. I mean, that is a vector, right? So I will say that character C out of this bucket of I, right? So I is basically the frequency and bucket of I is the vectors. So I'm taking every character from this vector, and so then what I will do is answer string. So I have an answer string answer, that is an empty string initially, and this answer string has an inbuilt method of append. So the first character is the frequency, which means I, because I is the let me just change this I to, let's say, just frequency. FRQ, right? Because it could be an ambiguous issue with FREQ. So now we have this frequency, and yeah, answer dot append frequency and the character, right? So these are the two arguments. So the first one will be the frequency, the number of times this character, the second argument, should be appended in the string. And after this part, we are good to go. We our answer string will be constructed, and we don't need sorting because we are traversing in the high frequency and then storing the elements. So we can then simply return S, or the answer. Okay, so it has to be decrementing. It is a decrementing variable because we're starting from the last part. Okay, let's submit it. Okay, and it is performing quite well. Let's see if we can even optimize it. You know, we are taking the worst case of the frequency, that is n. What if I tell you that the worst frequency will be the maximum frequency, right? And we are just making sure that it would be smaller than n or equal to n. So that's why we are taking n. Rather than, we can also make an optimization, and that is to use a variable called int max frequency, that is initialized with 0. And this max frequency will be equal to max of max frequency and the frequency map of C character, right? So this is the max frequency that we'll have, and then I will say that this is nothing but a max frequency plus 1, and in this case we don't want to start it from n, we can start it from max frequency, right? So yeah, let's see if this will work. Okay, it does works on the given test cases. Okay, it does work, although it's not that spectacular which I anticipated, but yeah, it is still fine. Yeah, it's still fine. So now the time complexity of this. So this part, that is the linear, this is a linear part, right? So the time function, let's write the time function, and this is order of n, right? When we are iterating over the string and keeping the count of the frequency of each and every character. And then we have bucket. Now this bucket will be, okay, this is also linear, because this is not actually linear, because this is somewhat like 26, right? It's constant time, because we have 26 different characters, maximum 26 different characters, and the map not 26, actually 127 different characters, or 128, because 0 is also the case in the ASCII code, which means that we can obviously have this as a constant time. And in this part, this is the max frequency. So the worst case would be n, right? In the max frequency, the upper bound will be n, And then for each and every character we are appending it into the string. I'm not taking this into consideration because this is very much similar, because we don't have a lot of elements, and the elements that we are adding is equal to the n, right? I think it makes perfect sense, because right in this case, if I'm traversing all of these elements, and if I take count of each and every element, then it will be equal to so what do I mean is, if I have a string and if I sort the string, the size will be similar, right? Which means that it is of n complexity. So the time complexity for this is also n, so the overall time complexity will be on upper bound of n. And space complexity, okay, this is interesting. Now space complexity, we are using a frequency, right, map which is of constant space, 26 pairs only. And then we have a yeah, so we are using answer, which makes it upper bound n space. And then we are using a bucket, and this bucket will be of much space, much larger space, that is n, but this is optimized to only the maximum frequency. So in even in the worst case it will be n, so this is order of n as well. So this is the time and space complexity. There's linear and linear, and this is the final solution for this problem. So yeah, I hope it helps, and if you still have any questions, you can comment in the comment section, and I will get back to you surely. So yeah, thanks for watching everyone. Have a good day.